Good afternoon, everyone. Welcome to another session of Physics Unveiled. And in this particular session, we are going to discuss a very important topic and interesting topic of class 11 physics, that is circular motion. We have divided the circular motion into two parts. First is the circular motion, kinematics of circular motion, and second part is dynamics of circular motion, where we are going to discuss about the different type of causes that that makes a body to move around a circle. Now, in kinematics part, we will be mainly focusing on the different kind of parameters, physical parameters that are needed to define the circular motions and its, magnitudes. Okay, like a body is moving in circular motion. What does it mean? What type of physical parameters are involved? What are the relations between them? So we'll be discussing all these things in this particular part. Okay, so without wasting much time, let's move ahead. So what is circular motions? So I have given a very simple definition over here that circular motion, whenever a body is moving along a circle with uniform speed or variable speed, the body is said to be in circular motion. Now we know that we have just studied about So suppose yes, the color is okay. Suppose the body is moving in this direction. Okay. So what you can see over here, like suppose the particle is at this position and after some time it is at this position. And suppose that the speed of particle is constant. In this case, the direction of velocity will be in this direction. And in this case, the velocity will be in this direction. So velocity is changing as direction is changing and direction of velocity is tangential. Right. So in circular motion, we'll be discussing in this particular two cases, like what will happen when the speed of particle is varying and what will happen when the speed of particle is constant. So let's move ahead. So in uniform circular motion, as I've already told you, that if the body is moving with a constant speed in a circular path, it is called uniform circular motion, but the velocity of the particle keeps on changing. As you can see in the diagram itself, that velocity, the direction of velocity is towards the tangent and it is constantly changing. So there must be, because if there is a change in velocity, we know from Newton's second law of motion, we know that if there is a change in velocity, if del v is not equal to 0, this means there should be some acceleration. And if there is some acceleration, it implies there should be some force. So we'll be discussing that what forces that are needed to move a body in circular motion. Okay, so we'll be discussing all these things as we move progress. Let's move ahead. I think so far we have cleared. Now, what are the parameters that are needed to define a circular motion? Now, see, I have just taken a very simple diagram over here. And in that simple diagram, I am showing that the body is at angle theta. Suppose this is the initial position of body. That I'm changing the color right now. Suppose it is black. So this is P and this is Q. Okay. At this particular angle, the theta 1, and this is the angle that is theta 2. So there is a change in angle. There is change in angle. Okay, again, let me choose the color. There is changing angle, and that is equal to theta 1 minus theta 2. Okay, so when a particle moves in a circle, its coordinates with respect to center changes. Suppose the coordinate of this particle is x1, y1, and at this particular point it will be x2, y2. Okay, so circular motion is nothing but a 2D motion. So there will be change in coordinate. Second, there will be the change in angular position. Okay, as we have already told you. Now, if del theta is function of time and the coordinate is changing, so there is some arc is also involved. Suppose this is ds. So ds is also changing, is a function of time. The radius vector, this is the radius vector or the position vector. OP is nothing but the position vector. Position vector. So OP is equal to magnitude of OP and OP dash are same, but direction changing. So there are three kind of quantities that we are seeing over here. First is the radial vector. The radial vector is nothing but the position vector of particle with respect to origin. There is an angular position. There is a change in angular position that is called the angular displacement. And there are two more quantities are involved. That is the angular velocity and the angular acceleration. So we'll be understanding these two as well. Okay. So let's move ahead. Now, suppose the particle is at this point P and it has traveled to this point Q. This is theta. This is the small displacement ds. This is the radial vector r. And we may write ds is nothing but r theta. Let's take this angle as d theta. Okay, small angle. Then ds and d theta both function of time. So you may differentiate it. ds by dt is equal to r d theta by dt. So we got the relationship v equal to r into omega. This is the rate of change of angular position. And this omega is called, this is called omega. This is called angular speed. And this is linear speed. Now, linear speed, if I call it as a velocity, and this I have to call as angular velocity. Now, when I'm calling it angular velocity, the velocity should have a direction as well. So, velocity, direction of velocity is towards tangent. And angular velocity, to find out the angular velocity's directions, we have to take the right hand thumb rule. Suppose if the body is rotating in clockwise, anti-clockwise direction, then keep your thumb in the direction of curl. Then your finger will give you the direction of angular velocity. This is the angular velocity. So in this direction, the angular velocity direction is upward. And if it is rotating clockwise, then it will be downward. The radial vector, this is the radial vector. It is always towards O to P, that is, it is radially outward. So you can see over here that V, direction of velocity, this is the direction of velocity, is perpendicular to radial vector, is perpendicular to the angular velocity. So in short, if we just denote in a vector diagram, you may write it as R cross omega. Okay, clear? Now, if we just further differentiate it, if V equal to R omega, if we just further differentiate it, so we may write as dV by dt is equal to R d omega by dt. That is nothing but acceleration, linear acceleration equal to R into alpha. That is the angular acceleration. angular acceleration. Okay, so these are the relationship between the linear acceleration and the angular acceleration, linear velocity and angular velocity. Okay, so let's move ahead. Now we'll be taking the relationship in more, at micro level. We have to understand that in what direction this velocity will act, in what direction this acceleration will act. So if you see that again, I'm just drawing this diagram. Now, if particle is moving, then this is the direction of velocity. This is the direction of radial vector. The radial vector. So in one sense, we may write that there are two unit vectors are involved. Unit vector basically gives the directions, and unit vectors are the directional vectors. These are directional vectors. So there are two types of directions are involved in a circular motions. So two types of directional unit vectors are there in a circular motion. First is tangential. First is tangential, and second is radial. Suppose tangential vectors are shown as ET and radial vectors are shown as ER. Then from this particular diagram, we may write ER unit vector is nothing but I cos theta plus J sin theta. And ET vectors, if this is theta, let's change this angle color. This is theta. This is 90 minus theta. Then ET you may write as minus I sin theta plus J cos theta. Now if this is a position vector R, then we may write R is nothing, the modulus of R into the direction of R, and that is towards radial. So R is R I cos theta plus J sin theta equal to R vector, position vector. Okay, if we just differentiate it, the change in position vectors, suppose this is, let's understand, if this is the one vector position vector and this is the another vector, then this is the change in vectors, and in this direction, if this theta is small, then this is the change in the direction of velocity as well, because if this velocity is here and this velocity is here, then this is the change in velocity. Okay, so this particular change you have to find out. So if position vector, if we just differentiate the position vector, we'll get the velocity vectors. So if we just differentiate it, dr by dt is equal to R I, this is sin theta d theta by dt plus J cos theta d theta by dt. So this shows d theta by dt is equal to minus I sin theta plus J cos theta. D theta by dt is nothing but the omega. This is omega. And this minus I sin theta plus J cos theta we may write as ER, ET. So this is ET. So this is the direction of velocity. The velocity is always acting towards tangent and its magnitude is R omega, as we have already proved. Okay, so this is the first part, the velocity, how the velocity and direction involved. The velocity is always acting towards tangent. So hence we have proved it. Now let us remove this particular thing. Okay. Okay. Now suppose the velocity is, we may write velocity is r omega et. Okay. Now if we just differentiate it again, then we'll get the acceleration. So dv by dt is nothing but r omega et. Et is this minus I cos theta d theta by dt plus minus j sin theta d theta by dt plus r omega et, r et, and this is d omega by dt. Let us remove this. Okay. Now let's remove, and this we may write as minus r omega square minus r I cos theta plus j sin theta is er. This is er unit vector plus this is d omega by dt, that is r alpha et. So v acceleration vector is a component of these two things, r omega square er plus r alpha et. Okay, we'll further discuss it. So let's go to the next slide. So in this particular slide, we are discussing about the acceleration that is involved. And as we have just derived the relationship between the acceleration and the unit vectors. So acceleration vector is nothing but minus omega square r er plus r alpha et. So in circular motion, there are two types of acceleration involved. First acceleration is called radial acceleration. Radial acceleration is minus omega square r, because see er is the unit vector that is acting towards outward center, but it's minus, so it is acting towards center. Okay, so this is the omega square r, and direction of radial acceleration is towards the center of circle, as unit vector is minus er. Okay, second vector is at, tangential vector. This is the tangential vector. Tangential vector is nothing but r alpha et. So direction is towards tangent. Direction is towards tangent. Towards tangent. Now, if speed is constant, then dv by dt is equal to 0. Okay, so there will be tangential acceleration is 0. So only acceleration is towards center, that is AC, and AC is omega square r, or omega equal to v square by r square. So that is v square by r. Okay, so let's see. So what is centripetal acceleration? The centripetal accelerations, we may define centripetal acceleration, the radial acceleration that acts on a particle while moving in a uniform circular motion is called centripetal acceleration. Centripetal acceleration. Centripetal acceleration magnitude is v square by r. Direction is towards center. And centripetal acceleration is always caused because of some external forces. Because if there is an acceleration, there has to be some force. The force is mass into AC. So mv square by r. So this is called centripetal force. So we're discussing about the centripetal force in our next session of circular motion. Now, if this girl is just rotating as a bucket in a uniform circular motion, you see the force that is acting toward tension, center is the tension. So here tension is the cause of, in this case, tension is the cause of centripetal force. So you should understand that whenever a centripetal force is acting, there has to be some cause, and that cause is always acting towards the center of circle. Okay. So in our next session, we'll be discussing about the dynamics of circular motion. Hope you have got the concept well. And we have discussed about the unit vectors and differentiations. So I'm not discussing all those things again in minute, because we have already have a playlist on our channel that is called Mathematical Tools in Physics and Vectors. So whoever have some issues in understanding those topics, I'll recommend them that please go to the playlist and clear your concept, and then visit this topic. And now the promotion time. I again urge you, please help us to spread our channel and share this channels with your buddies also, so that they can also get benefit out of it. And with this, have a great day, and thanks for your time.